Hey everyone, welcome to the channel. We're going to talk about Codeforces round 902 Div2. In this video, we will be solving problem A, B, C and D. Now, this is going to be a super useful video. I will be explaining the editorial, the problem statements, and also giving you a code walkthrough of the solutions. So this is going to be super useful. Make sure that you hit the like button, subscribe to the channel. If you want to appreciate the content I'm making, comment section is the correct place to go ahead and give a comment. Any feedback that you have for me that can help improve the video quality here, or if you'd like to see more videos of a certain kind, let me know in the comment section. I will be starting with problem A now. So there are n teams in a football tournament. Each pair of teams match up once. So there is NC2 matches. After every match, the number of goals of the two teams the number of goals the two teams score during the match are two integers. The efficiency of a team is equal to the total number of goals the team scores in each of its matches minus the total number of goals scored by the opponent in each of its matches. So before I move to explanation, what we're given is we are given the efficiency of first n minus 1 teams. We'd like to find out the efficiency of the nth team. Let's see what the efficiency of one of the team is. So efficiency A1 of the team 1 is goals hit by A1 team 1 minus goals hit on team 1 or hit against team 1. So this is majorly what A1 would look like. If you try to further break this equation down, let's see you have the scores of each of the match. So number of goals that the team 1 hit against some team 2 will be G12, and what we can say is we have an array GNN where G of ij is the number of goals so A1 can then be written as number of goals that the first team hits against the second team minus the number of goals the second team hits against the first team plus number of goals the first team hits against the third teams minus number of goals the third team hit against the first team, and so on till number of goals the first team hits against the nth team minus the nth team hits against the first team. This is your efficiency of the first team. How about the efficiency of the second team? It will be the number of goals the second team hits against the first team in the first match, and the first team hitting against the second team, subtract that. Number of goals the second team hits against third team and the third hits against second team, subtract it. Finally, in the nth match, number of goals the second team hits against the nth team and the number of goals the nth team hits against the second team. So this will be your efficiency A2. And similarly, I'm going to write A3 and AN. Goals that the third team hits on the second team and the second team minus the second team hitting on third team. So until in the nth match, number of goals that the third team hits against the nth team minus the number of goals the nth team hits against the third team. What we would like to find out is A of n. Number of goals nth team hits against the first team minus first team hits against the nth team. Let's see how we can find this. Let's try finding this one first. So if you look at this is the same as the minus of this G1n and Gn1. Take this to the left hand side of this equation and bring A1 to the right. Similarly, for finding this, use the A2 equation, or amongst these n equations, use the second equation. So on. For finding this one, use the equation of an minus 1. Now what you have to do is, your A of n is the sum, if you take these equations, your A of n is nothing but the sum of these all equations, the LHS. So sum these equations, all of them, you will get A of n on the LHS, because that is what we made, right? This thing is same as this one. This is same as this one. Add them all together all the way up to this one, you'll get A of n, the nth team's efficiency, which will be equal to negative of A1 plus A2 plus A3, so on till A of n minus 1, plus these other terms. Now what about these other terms? When you sum them all together from top to bottom, all these other terms are going to get cancelled out. G13 will get cancelled out when you write down for the third team. There will be a minus G13, and that will get cancelled out. Plus there will be a plus G31 in the third equation, that will get cancelled out. So try summing them up like this. All these other G terms are going to get cancelled out, and A of n will become equal to negative of the efficiency, sum of efficiency of all the other teams. Now I'll show you the code for the same. So if you look at it, I just input the efficiency of each team, keep summing them up negatively, and that's going to be my final answer of the nth team's efficiency. That's all. We'll move to problem B now. If there is any doubt, let me know in the comments. The problem B says that there is a village. The village has n residents and one chief. So a total of n plus 1 people. Now there is an announcement that needs to be made. If the chief were to make that announcement, the cost of making the announcement to one person is P. So if the chief were to announce it to everyone, then the cost is N into P. But every person, if there is a person P1, they know the information, then they have two qualities. One is a share capacity and other is a share cost. They can share the news further with more people less than equal to share capacity. So if their share capacity is 5, they can share the news with more people, they can share the news with less than equal to 5 people. So they can, this is AI is the share capacity. They can share the announcement to AI other residents, but the cost of sharing it would be BI, the share cost. So every person has these two qualities. Now given these people, you need to find out what is the least costly way of, so that everyone in the village knows about the information. Let's try this one maybe, or one of these examples you can try out on your own. But the idea is, a greedy solution works here. You will just keep sharing the information. The person who will be, so ideally everyone needs to know about the information. So it's best that the person for which the share cost is the least shares the information further with more people. Let me write down these observations. First thing is, total n plus 1 people, including the chief. Each person has two attributes: share cost, the cost of sharing. If this person shares the news to one more person, it's share cost, and the capacity of sharing, how many people this person can share the news further with. For the chief, The chief already knows the news. Rest n people currently do not know the news. For the chief, the share cost is P and the share capacity is infinite. They can share it with as many people as they'd like. For the sake of this problem, I can call it n plus 1. And since the chief already knows the news, but the other people are yet to know the news, what can we deduce from that? The overall cost is going to be at least P because chief has to share the news at least once. Now, it might be possible that once they have shared, they share it with a person whose share cost is super low. Maybe there's some person who loves to spread all these newses and they'll just go and tell everyone for no cost at all. So the chief would like to share it with someone whose share cost is as low as possible. And that person will further share it with another person whose share cost is as low as possible but might be greater than their own. So let's say the person with the lowest share cost is P1. Chief will be sharing the news with P1. P1 will further share the news with P2, and if capacity allows, they'll also share with P3, P4, whoever. And this is assuming that the share cost of P1 is lower than P2's, lower than P3's, lower than P4's. They'll keep sharing it further. Then maybe let's say P1 could only share it to P2, P3 and P4. Next would be P2 will share this information with P5 because P2 has a lower share cost than P3 and P4. So maybe P2 will share with P5 and P6. And it might be possible that now P2 cannot share further and we reach P3. And it is a possibility that chief has a lower share cost than P3. Then what will happen is rather than using P3 to share the news further, we'll just use chief to spread the announcement to remaining people. And you don't need to go to other people because chief has an infinite share capacity. So the idea is wherever possible, try to minimize the share cost. I'll show you the code. If you have any doubts, put them in the comments. Happy to answer. Happy to make a more detailed video only for B or only for the other two problems too. So what I did was I just take the number of people in the village as input and the share cost of the chief. Then this people info contains the share cost and share capacity for each of the person in the village. I have input both the things share cost, share capacity, and finally I also add the chief's share cost and share capacity into the people info array. After this, I sort this array so that the person with the lowest cost is at the front of the array. My cost is going to be at least P as we discussed in the observations here, because the chief has to share the news at least once. And the number of people the news is already shared with is 2. Chief already knows the news. The one person chief told also knows the news. Now I'll iterate over all the people till the number of people who know the news is equals to the total people. The number of people left to share is total people minus the number of people who already know the news. Now, if the current person can tell this news to everyone, great. Shared people will become equal to the total people and cost would be whatever is the share cost for this person into number of people they are sharing this news with. Otherwise, if this person cannot share the news with everyone remaining, then simply the number of people who know this news will be plus equal to the share capacity of this person, and cost will be equal to the number of people they are sharing this news with, the share capacity into the share cost. That's all. So this would be the solution to B. I'll be moving forward to this problem C now. You can maybe pause here, try to digest the solution, and we'll start with the next problem now. So this is one of the problems I really enjoyed solving in this contest. Now the problem says there is an array of size n plus 1. The n plus 1th element is something that we have to select, and this n plus 1th element will be an integer between 0 and m. Rest of the remaining integers will get fixed after you select the n plus 1th element. So after you have selected an plus 1, an is going to be an plus 1 modulo n, and a of I is going to be a of I plus 1 modulo I. So current element will be whatever is the right element modulo current index. So as an input you're given n, m and k. You have to find out the number of ways in which you can select the n plus 1th element, so that in the remaining array, the number of distinct values is exactly equal to k. Let's take one example. So we have n, m and k. N is 4, so your array size is 4 plus 1, 5. The fifth element is something that you have to select. Now the fifth element has to be between 0 to 6. And the number of distinct elements in this array after you have selected the entire array has to be 3. Number of distinct values should be equal to 3. What happens if I put 0 as the last element? This will be 0 mod 4, which is 0. This will be 0 mod 3, which is 0. So there is just one distinct value in this array. So this is something I will not select. Similarly, what if I put the last number as 1? This will be 1, this will be 1, 1 and 0. So this is also something I'll avoid. How about I select 2? So if I select the last number to be 2, then this will be 2, because 2 modulo 4 is 2, 2 modulo 3 is 2, 2 modulo 2 is 0, and this will be the array. The number of distinct elements in this array is also 2, 0 and 2. Similarly for 3, the array will look like this, and 4, the array will look like this. How about 5? So this will be 5 mod 4, which is 5, and this will be 5 mod 3, which is, sorry, the last element I select to be 5, this will be 5 mod 4, which is 1, this will be 1 mod 3, 1, 1 mod 2, 1 and 0. Now the number of distinct elements is 3, which is what we desire. So we'll count it. Similarly, if the last element I select to be 6, this will be 6 mod 4 is 2, this will be 2 mod 3 is 2 and 0. Again, distinct elements is 3. So your answer is a total of 2 possible ways. All these 4 got ignored. Now, I hope you understand the problem correctly, and we'll see what the solution is. The solution is pretty fun actually. Let's write down the observations first. So A0 is always going to be 0 no matter what. Sorry, A1, the first element. Since anything or x modulo 1 is always 0. So A1 is equal to A2 mod 1. Whatever A2 is, it is x or whatever, it's going to be always 0. This array is always going to be non-decreasing or increasing, because modulo always returns a smaller number or the same number but nothing greater. So array will always be non-decreasing. What else? Once if ai is 0, then all the remaining elements will also be 0. Then a1 equal to a2 equal to so on until ai equal to 0. These are some observations, but now what we'll do is we'll try to solve the problem for k equal to 1 distinct values. Since there is just one distinct value in the array, no matter what you put at the last element, the first element has to be a 0 from our observations. The last element, if it is anything other than 0, 2, 3, x, anything other than 0, there will be at least two distinct values, 0 and that number. So the last number has to be 0, and from our observation, this array becomes 0, 0, 0, 0, 0, 0. So k equal to distinct values, there is just one possibility. Use last number as 0. And that's all. For k equal to one distinct value, the output is 1. You have to use the last number as 1. How about k equal to two distinct values? So first element will always be 0, that is one distinct value, and the last one that you use. Let's say if you use 0, that's not going to be counted, it will be one distinct value. But how about you use maybe 1? This will always be two distinct values because your array is always going to be non-decreasing. So it's going to be 0, 0, 0 followed by some ones, nothing else. So a group of zeros and a group of ones. This will always be two distinct values. How about 2? Now let's assume n equal to 100 maybe, whatever. So if the last element is 2, is it possible to get three distinct values here? Think about it. Can you get 0, 1 and 2, all three elements in this array? The answer is you can never get all three elements. You will only get zeros followed by some 2s. Reason? Because this is going to be 2 mod 100, which is 2, then 2 mod 99, which is 2, so on till 2 mod 3, 2 modulo 3, which is also a 2, and finally 2 mod 2, which is a 0. Similarly, if you select any element here, x, so that x is less than n, it will be x modulo a number larger than that, which will always be x, up to x modulo x plus 1, which is again x, and then x mod x, which is 0. So if you select any number on the last index which is less than equal to n, it will always give you two distinct values. So all the numbers from 1, 2, 3, 4, so on till n minus 1 and then n will give you two distinct numbers exactly. N will also give you two distinct numbers because if you keep n plus 1th number as n, then an will become n modulo n, which is 0, and two distinct numbers will be all the array is 0 and last number is n, so 0 and n. Also, any number that is a multiple of n will also give exactly two distinct values. Why is that? Same reason that is for n. If you keep the last element as so 0, blah, 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 last number is multiple times n, this number will become 0 because mul times n modulo n becomes 0, and then you have two distinct values. So for k equal to 2, these are two scenarios. Let's try k equal to 3. So we know that k equal to 3 is not possible for any number so x is the number I'm placing at the last position. Not possible for any number 0 till n, we already tried out. Also not possible for any multiple of n, x equal to n times some multiple. What about n plus 1? Let's try n plus 1. So n plus 1 modulo n is going to be 1, and then this array will be, this one is simple. Now till you get 1 mod 1, it will stay a 1, and finally 1 mod 1 will be 0, rest all will be 1. So this is exactly 3 distinct values. How about n plus 2? Again, n plus 2 modulo n is 2, and then this will be a 2 all the way till 2 mod 2, which becomes a 0 then. This is again 3 distinct values. How about n plus 3? Same thing will happen again. N plus 4. This will keep happening all the way till 2n minus 1. 2n minus 1 modulo n would be n minus 1, and then n minus 1 modulo n minus 1 will be 0, and there will be 3 distinct values. At 2n, it will follow this rule to give you k equal to 2 distinct values, and then at 2n plus 1, again 2n plus 1 modulo n would be 1, and same thing will follow. So anything follow starting from here, you can see the pattern. It will always give k equal to 3 distinct values if x is greater than equal to, if x is greater than n but not a multiple of n, and no other value of k is possible. K equal to 1, 2, 3, nothing else is possible, and that's all. Solution for this is pretty straightforward. K equal to 1, it has to be everything 0, so 1. If m equal to 0 but k is not equal to 1, it's not possible to form anything related to that, because last number is 0, k has to be 1. Everything will be one distinct value, which is 0. Similarly, as I explained for k equal to 2, if the number of attempts I can do at the last is greater than equal to n, include all the first n minus 1 numbers followed by any number that is a multiple of n. Include those. Yeah, there's nothing much to explain. Exactly what I did there, I wrote it down in code. If you have any doubt, let me know in the comments, and we'll move to the problem D now. Hope you like this. Do leave a like, that motivates me to make more content like this. So this is another good problem. Now there is an array from A1 to AN. Chanika will select some indices and paint those indices black. For the selected indices which are black, we will now select all the multiples of a given index and paint them green. Finally, what all indices are black and green, pick the maximum value amongst those, and that is going to be your score for that selection. Like this, Chanika will select all the possibilities. So there are a total of 2 to the power n subsets of this. Since you need to paint at least one of them black, there is 2 to the power n minus 1 subsets of this. Play out every possibility. Paint paint one subset as black. Paint their multiple indices as green, and then see which is the maximum amongst them. That is the score for that configuration, and then sum that up, give that modulo this thing. So they didn't give a small example, but I'll give you a small example so that we know we are on the same page. Let's take the array 2, 3, and 8. One of the possible selection is paint the index 1 as black, then everything is black, then index 2 and 3 are green because you painted 1 as black. The score will be 8. Similarly, you could have painted the index 2 as black, then there will be nothing as green, and score would be 3 because that's the largest element in the only element 2. Similarly, let's try 3. If you would have painted 3 as black, then black would have been 3, green would have been nothing, score would have been 8, the third element itself. Similarly, you could have picked 1 and 2 as the black ones. Then green would have automatically been, due to 1 painting 2 and 3, green would be 1, 2 and 3, all of them. Sorry, 2 and 3. Score would be 8. Similarly, pick 1 and 3. Now you're getting the idea. There is going to be exactly 2 to the power 3, 8, minus 1, 7 such options. Sum their scores. Score is 8 here because you have 1 and 2 as black, 2 and 2 and 3 as green. So 1, 2, 3, all these are colored. The maximum of the colored items is 8, therefore score is 8. Amongst these, take all of them, sum of these scores, give them modulo that value that's written there. This is the overall problem. Now I'll give you a good solution for it. You can definitely do this in 2 to the power n into time taken to coloring time. Worst case, this could be n. Maybe you can do better. I believe it can be done better, but let's say 2 to the power n or 2 to the power n square is the solution if you were to do it in a brute force manner. But we can definitely do it better. So what we'll do is, let's write down our arrays a1, a2, a3, a4, a5, so on till a of n. Now what we'll do is we'll do the contribution trick. Instead of saying the number of elements or the score of a given configuration, we'll think about in how many configurations is AI the largest. And if we were to know the number of configurations that have the score AI, we can just multiply that. Let's call this number of configurations as num I. So num I is the number of configurations in which the element at the ith index is the largest. Should I name it something else instead of num? Maybe config that I. Or let's keep it num. Let's call num at I equal to number of configs. So your overall answer is going to be num and you get the idea. So this will be your overall score. Only problem is how do you calculate this num1, num2, num n. So what I'll do is I'll start off with the largest element in this array. Let's say the largest element in this array is AL and it's at index L plus L1. So let's say the largest element is at index L1 and is A of L1. Let's say the second largest element in this array is A of L2 at index L2. And the smallest element is at the index A of Ln. Let's try to find num of L1. Can we do that? Of course we can do it. So in what all configurations will L1 get selected? So if any of the index I is painted black such that L1 modulo I is 0, these are all those configurations in which L1 will get selected, and since A of L1 is the largest, it will definitely be the score since it's getting selected. That's all. We are not bothered what else gets selected or missed. If L1 index is getting selected, it has to be the score of the game. And num of L1 is if you are selecting any index I, selecting any index I such that, yeah, such that I is painted and L1 mod I is 0. Now, how many such indexes can be there? That's easy. You can just go over all the indices, find out, okay, 1 divides it, this divides it, that divides it. So you'll have a set of indices, maybe K1, K2, K3, and so on till L1. Right, L1 itself will divide itself and nothing greater than that will divide it. So assume K1 less than equal to K2 or K1 less than K2, K2 less than K3, so on till less than L1. So if any of these is selected, great. If more than one of these selected, also great. So assuming these are a total of G, assuming these are a total of G indices that that like follow this property, I is painted black. So you basically wanted only one of these. So any subset of these G indices is good enough for me. At least one of them getting selected. So there are a total of 2 to the power G such indices minus 1 because ignore the empty subset. This will be num of L1. And then the contribution will simply be num of L1 into A of L1. So this should be good enough. I hope we are all clear here. Also, actually num of L1 would be 2 to the power G minus 1. Select at least one of these and in the remaining indices, for the remaining indices. So there are other n minus G indices also. Whether they are selected, missed, all of them are missed, all of them are selected, I hardly care. I just need to make sure that one of those G was selected. For the remaining ones, anything is fine. So that would mean any subset, even the empty subset is fine. That is, nothing is getting painted black, all of them are getting painted black. So 2 to the power n minus G. That's great. Let's try to find out num of L2. This is going to be slightly hard. Why? Because this still needs to be followed. Select any index I such that L2 mod I is 0. But there is one more rule. I should not, and I modulo L1 modulo I is not 0. Think about why is that. Because if you select an index I that divides L2 and also divides L1, then that would mean it's a case we have already considered. The score is not going to be A of L2. The score is going to be A of L1, which is already considered here. We are thinking about only the contributions of A L2 now. So L1 should definitely not be painted either black or green. And that is why this condition also needs to follow, that the index I that you are painting black is not dividing L1. So now what will happen is you will have a set of elements like K1, K2, K3, so on till L2 minus there will be set difference. Let me call it K1 1, K2 1, K3 1, and L1 is fine. Or maybe instead what I can call them is P1 minus this. So these are the set of indices you care about, and size of them, let's call it a total of So these are the good indices, but since we want to exclude the L1 ones, we have to exclude these also, and this will be a total of Q indices. So amongst these Q indices, you can pick any. You just want one to be, at least one to be picked, and rest you are okay. So any subset of these Q indices is good. Now in the remaining ones, definitely these G should not be picked. So remaining is N minus Q minus, yeah. So the G indices for this one should definitely be not be picked. So that's just one such way. And overall, in the remaining N minus Q minus G, anything you pick or not is totally fine. That's it. Similarly for num L3, everything same will apply, only that these two things, this union this should not be picked. So what I'll do is I'll traverse from the largest to the smallest element and see what all such things are already covered. So what all indices were already used for contribution of a larger element. I will keep a track of those indices and not pick them. So if there were some good indices, I would subtract the previous ones from it. So let's move to the solution. And yeah, if you need a more detailed video, feel free to add that in the comments. I'm happy to elaborate it further. But since it's a video for the entire round, I'll try to keep it a bit brief. So what I did was I took the input and I formed a traversal order. So traversal order contains the element I and its index, and then I sorted them based on the largest to the smallest. So this traversal order has the largest element at front along with its index and the smallest element at the last along with its index. So A of L1, A of L2, A of L3, so on. Next, I created an array called divisor indices. So divisor indices at X tells me what all elements or what all other indices divide X directly. Finally, once I have this ready, I try to solve the problem with this method. So I'm keeping a track of while I'm trying to find the contribution of some element AI, I'm keeping track of all the elements larger than this already seen and for which I already covered some of the indexes as black, and that should not be considered now, because if I color those black, one of the larger ones will get colored and that the score will not be equal to A of I. I want the score to be A of I, the score will be larger than that. So I'm keeping a track of all the all the ones that should definitely not be colored to make sure that this element is the score. Previous count is 0. This is nothing but the number of elements in this array that are equal to true. Marking this array as false. Overall score initially is 0. I'm going to use exactly this formula to calculate my overall score. Now, in this traversal order, I get the index of the first element, or basically L1, the value that is A of L1, then indices if colored black will color current element, count of indices should definitely not be covered, and then a good index is the index that if colored will color your current index. So every index that divides the current index is a good index. If this is allowed to be colored black, I will color it black. I'll push it that this is one of the good indexes, and previous count I'll keep coloring for the next element. I've already stored prev count for now, and this previous count will be used in the element smaller than the current element. Then finally, overall score will be the same formula I showed you previously. This one. I'll try to explain it there as well. So what I'm doing is current number index val. So current value multiplied by 2 to the power the good indexes for this and amongst the remaining take anything. So remaining will be n any previously seen and the good indices dot size. Okay, yeah, minus this minus the previously seen ones. That's it. If you have any doubts, let me know. Hopefully this is clear. If not, happy to explain it in comments or make a detailed video specifically for problem D or any other problem. Make sure that you hit the like button and subscribe to the channel. Thanks for watching. Bye bye.